The Webb telescope is seriously far away. It's picking up light that's been traveling for over 13 billion years. The crazy thing is, the universe has been getting bigger the whole time, which means the light has been stretched out too. When we look at the most distant stuff, we're basically looking back in time, almost to the very beginning, the Big Bang. It's hard to wrap your head around how enormous the universe is, but get this, everything started from a tiny point called a singularity. That's how we think the Big Bang went down, anyway. The James Webb Space Telescope, JWST, has been dropping some knowledge bombs about how the universe was born and how it's grown up. It's kind of mind-blowing. Brian Cox, the famous physicist, even said that what the JWST is finding could totally change the way we understand everything. Let's check out how these space discoveries might shake up what we know. The James Webb Space Telescope, named after a big shot at NASA, is a real feat of engineering. It's better than the Hubble Space Telescope thanks to a teamwork effort by NASA, some Europeans, and Canadians. It uses the latest tech and is designed to zoom in on the universe in amazing detail. Unlike Hubble, the JWST takes super clear pictures of stuff that's really far away. It mainly uses infrared light, which is cool because it can see through space dust and spot things we couldn't see before. It's got this huge 6.5 m mirror made of 18 sections, and it hangs out about 1.5 million kilometers from Earth, orbiting the Sun with us, so it always has a good view. When it looks way out into space, the JWST isn't just seeing light years away, it's seeing back in time. Because of the expanding universe, light from super distant objects gets stretched into the infrared. JWST can pick up this infrared light, allowing scientists to study how stars are born, how galaxies grow, and even peek at the air around planets outside our solar system. One of the coolest things the JWST recently spotted was a ton of galaxies way out at the edge of what we can see. This is messing with what we thought we knew, and it's time to rethink some basic ideas about the universe. To get how wild this is, let's take a quick look at space history. The ancient Greeks and Chinese were the first to watch the planets. Then, in the 1600s, Newton came up with laws that explained how things move in space. In the 1900s, Edwin Hubble made some huge discoveries. He figured out that those fuzzy things in the sky were actually whole other galaxies way beyond our Milky Way. He also showed that the universe is getting bigger, with galaxies moving away faster the farther out they are. After World War II, the space race started between the Soviets and the US. The Soviets launched Sputnik, the first satellite, and sent Yuri Gagarin into orbit. Then, in 1969, the US landed Apollo 11 on the Moon. Fast forward to 1990, and the Hubble Space Telescope gave us amazing pictures and new info about the universe. From those early skywatchers to the JWST, it's incredible how far we've come in understanding space. For instance, Hubble gave us the famous Pillars of Creation picture in the Eagle Nebula, showing a star nursery. It also took the Hubble Deep Field image, revealing thousands of galaxies in what looked like an empty part of space. The HST even checked out the atmospheres of planets outside our solar system, finding water and other elements that might hint at the possibility of life. By observing the supernova 1987A, it helped us understand how big stars live and die. The James Webb Space Telescope is building on all of that, using better tech and everything we've learned from Hubble. One of our best guesses about where the universe comes from is called the Big Bang Theory. It suggests that about 13.8 billion years ago, the universe was super hot and dense. Then, it rapidly expanded, creating matter, energy, and all the forces we know. As it cooled down, things like atoms, stars, and galaxies started to form. The Big Bang Theory also explains the cosmic microwave background radiation and the amount of light elements we see. Even though it's widely accepted, the Big Bang Theory had its doubters at first. Some scientists proposed other ideas, like the steady-state theory, which suggested the universe always looked the same. But over time, more evidence supported the Big Bang. One major piece of proof was the discovery of cosmic microwave background radiation in 1965. Space missions and technological advancements have continued to back up the theory. Now, we have the James Webb Space Telescope. With its advanced infrared instruments, it can see through space dust and pick up light from the oldest objects in the universe, some formed right after the Big Bang. Since it uses infrared light, it can observe star formation and how they're made, even if they're hidden behind clouds of dust. Infrared light is useful because it has longer wavelengths than visible light, allowing it to pass through dust. The JWST can also detect cooler objects that only emit infrared light, like exoplanets and distant galaxies. As objects in space move away from us, their light waves get stretched, making them look redder, a phenomenon called redshift. The JWST can detect this redshifted light, allowing it to see far into the early universe. It can also observe exciting space events, such as black holes merging or new stars forming, as they emit a lot of infrared light. The JWST works alongside other telescopes, like Hubble, to provide a more complete picture of the universe's evolution. By capturing different wavelengths of light, scientists can better understand how the universe has changed over time. In a way, the JWST is like a time machine, allowing us to look back at the very beginnings of everything. Just recently, the JWST discovered something that could challenge the Big Bang Theory itself, a group of massive galaxies existing just a few 100 million years after the Big Bang. The puzzling part: we don't know how they got so big so fast. This discovery might change how we think galaxies formed in the first place.